All right, yeah, I think you're going to be the first person in the video. All right, so here we are. We're doing the warm up, and it says to graph the system of equations to find the solution. So I'm going to start with my y-intercept, that right there in that equation, and it's at 0, -1. So here I have my y-intercept is right there. Next, I can see that my slope is 2/3. And remembering that slope is delta y over delta x, that says to go up 2 and to the right 3. So up 2 and to the right 3, we'll put a point right there at 3, 1. So 3, 1. And then I can just continue to follow that pattern, up 2 and to the right 3, up 2 and to the right 3. But it's also important to remember that the fraction 2/3 is equal to the fraction -2 over -3. So from my y-intercept, I can go down 2 and to the left 3. And that will also help me to plot some more points on my line. So I can connect all those points with a nice line, straight as I can get. And there it is. I could also do something nice. I could say, hey, that's a y equals 2/3 x minus 1. All right, so that's that equation. The other equation, let's see, it's not written in y equals mx plus b form, but I could easily write it in y equals mx plus b form. And the way I could do that is I could subtract 2x from both sides. And what I get is y is equal to -2x plus 7. So my y-intercept there is 7, and my slope is -2, down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. Oh, I went down 3 the first time. Nobody caught me on it, but I did. Woo, that was close. All right, so there are all those points that are on my line. And that is the equation, my original equation, 2x plus y is equal to 7. And I can see that the place where those two lines intersect is right there at the point 3, 1. That is my solution to the system of equations. Are there any questions on that problem? Jocelyn has a bunny that weighs 5 pounds and gains 3 pounds per year. Her cat weighs 19 pounds and gains 1 pound per year. When will they be the same amount, and how much will they weigh? So, when we're doing word problems, it's usually a good idea to read the whole problem first without doing anything. Just read it. And then go back and think about, okay, well, what are we looking at? We're looking at a situation where we have this bunny that weighs 5 pounds now and gains 3 pounds per year. And then we have this other situation where her cat weighs 19 pounds and gains 1 pound per year. So it looks to me like there are two systems or two equations here. And so we're going to first decide our variables. So x is going to equal the number of years. And y, I should have written that in a different color. Sorry, let me change that. And y is going to be the weight in pounds of the animal. All right, so our equation then is we have two equations. For the bunny, we have y is equal to, let's see, if it gains 3 pounds per year, then that's the growth factor. And remember the growth factor in y equals mx plus b? This is the growth factor right here. And this is the starting value. So we have gains 3 pounds per year and right now weighs 5 pounds. And with our cat, it gains 1 pound per year and weighs 19 pounds. When will they be the same amount and how much will they weigh? So we're going to use the substitution method here, and we're going to take this 3x plus 5, and because it equals y, we can plug it in for that y right there. So I'm going to take these, and I'm going to come right up here, and it's going to be 3x plus 5 is equal to 1x plus 19. Questions so far about writing the equation, those two equations, or using the substitution method? To solve, my first step is going to be to get all of my x terms on one side. I'm going to subtract 1x from the right and the left. That'll create this 0 right there. And on the left, we'll have 2x plus 5 is equal to 19. Now, to get my x term, the 2x by itself, right here I'm adding 5 to it, so we need to do the inverse of adding 5, which is subtracting 5. So we get 2x is equal to 14. My next step, well, I have 2 times x. The inverse operation of multiplication is division, so I divide by 2, and I get x equals 7. So I've solved the equation, but since x is the number of years, that means that in 7 years they're going to weigh the same. But I also want to know, and how much will they weigh? Well, y is the weight. So I still need to do some work. I need to plug x is 7 into either one of my equations, and then solve for y. I'm going to use the cat, not for any particular reason, just because. Okay, so I'm going to have y is equal to 1 times 7 plus 19. So I just plugged my solution, x is 7, in for x right there. So I have y is equal to 7 plus 19, y is equal to 26. So the answer here is, in 7 years, both animals will weigh 26 pounds. And that, whoa, sorry folks, there you go. And that is the solution. Questions on any of that? All right. Yeah. You just figured it out as you were talking it through? Great. Hi, Lucy. Hi, Savannah. Glad you're here. All right. Any other questions before we move on? Bless you. All right. So here are the two equations that we just found. And we can see that when we graph those two equations, we find the xy coordinate pair that we just found using the equations to solve. We used the substitution method. So why might we want to use the substitution method instead of graphing for this problem? Anybody have any ideas? There could be some different reasons. For me, yeah. So you're saying this equation method is harder than graphing? Hmm. I wonder if it does. I mean, well, I think that graphing, let's say you don't have, this looks like it came from Desmos, I'm guessing. So let's say you don't have Desmos and you have to graph this by hand. Yeah, it does depend. I think you're right, Mia. So if you have Desmos, I think that once you find the equations, throwing them into Desmos is probably a great idea. But if you don't have Desmos and you don't have graph paper, well, that's a real problem. If you don't have graph paper, it's hard to get this all lined up correctly on just lined paper like this. If you just have lined paper, then graphing and finding the actual points tough. And if you do have graph paper, it still may be hard to make sure that you get those lines just right so that you see the exact point where it's crossing. So those are the reasons why it might be better to use the substitution method. Some reasons. Can anyone else think of other reasons? That's one other good reason. Yep, yep, good. All right. Now I want you to take about 3 minutes to see how far you can get solving this system of equations using the substitution method. Take about 3 minutes. And if you are watching this online, then pause the video right now and give yourself a few minutes to try to solve it. I will give you a hint before you um, get going. All right, so however far you got, that's just fine. I'm going to go over this now. So what I showed here is that because x is equal to y minus 2, we can take that y minus 2 and plug it in for x. So here I have 3, and then times the quantity y minus 2, I'm plugging it in for x, plus 2y is equal to 18. So that is the substitution part of the substitution method. And the reason why it works is because now we are only dealing with y, the y variable. The x variable is taken out of the equation. Our first step in solving here is going to be to distribute the 3. So we'll have 3y minus 6 plus 2y is equal to 18. On the left-hand side, we can combine the 3y and the 2y. We'll have 5y minus 6 is equal to 18. The next step here is to isolate the y term by doing the inverse of subtracting 6, which is adding 6. So we get 5y is equal to 24. Since 5 is multiplied by y here, the inverse operation of multiplying by 5 is dividing by 5. So we have y is equal to 24 over 5. And that's a fine way to have a number. It's an improper fraction, but generally I don't mind it. We could rewrite it. 5 goes into 24 4 times with 4 left over, so it's 4 and 4/5. What I mean by that is 24 divided by 5 is 4 and some left. And so we do 5 times 4 is 20. 24 minus 20 is the 4. And that's how we get the 4/5. Okay? Sure. Yeah. 4.8 is also a perfectly appropriate answer. Thanks, Jojo. So we have a value for y, but we need to solve for x as well. And since this equation is already solved for x, it's the easiest one to plug a value of y in for. So we can do x is equal to, and I'm going to do just 24 over, I'm going to do 24 over 5 because I want us to do the fraction work, all right? So minus 2. Whoops, that should be in black. Minus 2. So how can I subtract 2 from this fraction? Well, I need a fraction where the denominator is 5. So I have the 24 over 5 minus something over 5. So what fraction is equal to 2? Oh, and with 5 in the denominator. Well, it's 10. 10 over 5. I can get that by doing 2 times 5 is 10. Okay. So now, in our subtraction here, we have common denominators. So we do 24 minus 10. Well, that's 14 over 5, which is 2 and 4/5, or 2.8. So our solution is 14/5, 24/5. And are there any questions on that? It would be perfectly fine to write that as decimals. Let's take a break. I just saw a yawn, which means we need to move our bodies and get the blood flowing to our brains. Now, take a few minutes to solve this one using the substitution method. Be careful. It's not in a form right now that you can solve by using the substitution method. You need to do something. If you're doing this online, go ahead and pause the video. We're going to substitute negative 3x plus 5 in for y. So we have 5x minus 4 times the quantity negative 3x plus 5 equals negative 3. I'm going to distribute. And one thing you have to be careful about distributing here is distributing the negative 4, not just a positive 4. I've seen that give people some trouble every now and then. Whoops. So it's going to be a 5x plus 12x minus 20 equals negative 3. I can combine those x terms right there, and I'll get 17x minus 20 equals negative 3. To isolate my x term, I need to add 20 to make a 0 there. Whoops, not 12, it's 20. So I get 17x equals 17. Now, I need to isolate my x by dividing by 17, and I get x equals 1. And I can plug that 1 in for x in either of my two equations. It doesn't make any difference because basically they're the same layout. The one thing I see is that this one is just y, and this one's a negative 4y. So it looks like this one might be easier to use to solve. So that's the one I'm going to use. So I have 3 times 1 plus y is equal to 5. Well, this is 3. So to solve here, I can subtract 3 from both sides, and I get y equals 2. So my solution to this system is the point 1, 2. Now, if I were going to check that, what would I need to do to check it? And we are going to check it this time. Yep. In one equation or both equations, Jojo? Yep, you've got to check it in both. Great. So we have, on the first equation, 5 times 1 minus 4 times 2 equals negative 3. Well, 5 times 1, that's 5. Minus 4 times 2, that's 8. Equals negative 3. And negative 3 is the result of 5 minus 8. And it does equal negative 3. So that one checks. Now we have to check the other equation. So 3 times 1 plus 2 equals 5. 3 times 1 is 3 plus 2. 5 equals 5, and that one checks. So what this tells us, we've just checked the point, which we found to be our solution, in both equations of our original equations, and we found that it was a solution to both equations. So we know that those two equations are crossing at that point. Any questions on this one?